Hello everyone, this is Dr. Tripti Saxena. In this session, I will tell you about preparation and evaluation of self-emulsifying drug delivery systems. In previous session, we have already discussed about formulation components of SMEDDS. So now we know that the main formulation components are oils, surfactants and co-surfactants. So step 1 in the preparation of SMEDDS is screening of all these three main excipients. How we do it? With the help of solubility studies. For that, we take various types of oils, surfactant and co-surfactants. Among them, we need to choose the best oil, best surfactant and best co-surfactant. That we do with the help of solubility studies. For that, we take all the solvents and we add excess amount of drug in each of the solvent, and we put the samples in orbital shaker for 3 days at 25 degrees Celsius. That gives us saturated solution of the drug in the solvent. Then we need to remove the excess amount of drug which is present in that saturated solution, and that we do with the help of centrifugation. So we centrifuge the equilibrated sample and then we do favorable dilution, and finally we analyze the sample for the drug content or the quantity of the drug which is present there. So based on that, we select the oil, surfactant and co-surfactant which shows maximum solubility for the drug. So this is all about the first step, which is screening of the excipients. Now we have the best formulation components with us. Next step is to find out the correct combination of these components. So that we do with the help of pseudo-ternary phase diagram study. In this particular study, we find out the correct composition of oil, surfactant and co-surfactant. In the previous step, step 1, we have already screened out the best components. Now we have to find out the best composition of these three components, which gives us microemulsion region. I will show you first one pseudo-ternary phase diagram for your better understanding. Here you can see this is a triangular, this is ternary phase diagram, triangular shape diagram. So here you can see this is oil, this is S-mix and this is water. S-mix is nothing but the mixture of surfactant and co-surfactant. So here the 100% concentration is there for S-mix. It shows the 100% concentration of oil and it shows the 100% concentration of water. To do this study, we need to mix S-mix and oil, and that mixture we need to titrate with water. As soon as we add water to this mixture, we will get either cloudy emulsion or we will get clear emulsion, which shows micro or nano size droplet. So here in this diagram, this particular region shows the presence of micro emulsion. So in this particular region, whatever combinations we will prepare, it will give us micro emulsion on dilution. Whereas in this area, whatever combinations we will try, that will give us coarse emulsion on dilution. So in this way, with the help of pseudo-ternary phase diagram, we find out the correct composition of oil, surfactant and co-surfactant, which gives micro emulsion region. And finally, the third step is addition of drug. Now we have the various combinations which is going to give us micro nano emulsion on dilution. So with each and every combination, we can go for addition of drug, and that will give us drug loaded formulation. So we just need to dissolve the required amount of drug with the formulation, and that we can do with the help of gentle stirring, and we also can convert this liquid SMEDDS formulation into solid SMEDDS, and that we do with the help of solidification using solid carrier. So we can use any absorbent material like fugicalin and Avicel, etc., and we can directly adsorb liquid SMEDDS onto that powder to convert it into solid form. So this was all about the preparation part. The next is evaluation part. So evaluation of self-microemulsifying system. So the first test is self-emulsification time. So this is the time which indicates the spontaneous nature of the resultant emulsion. So that shows that how spontaneous is emulsion formation after dilution. For this, we need to add SMEDDS formulation with water and 0.1 normal HCl, and then we can monitor the tendency to emulsify spontaneously and final appearance of the emulsion. Generally, if the self-emulsification time is less than 20 seconds, that represent that the resultant emulsion is spontaneous. Second evaluation test is precipitation assessment. For that, we need to add again these SMEDDS with 0.1 normal HCl and water, and then we store the resultant emulsion for 24 hours and observe this particular resultant emulsion for phase separation and precipitation of the drug. Third test is related to the robustness of the resultant emulsions to dilution. Here we need to dilute the emulsion, the resultant emulsion to 50, 100 and 1000 times, and then we need to store the emulsion for 24 hours, and then again we observe it for phase separation and precipitation of the drug. If it shows any type of precipitation of the drug, that means it is not a robust formulation. Next evaluation test is in vitro drug release study. So in this, we need to fill the formulation into hard gelatin capsule of size 0. So whether it is a liquid formulation or solid SMEDDS formulation, we need to fill it into hard gelatin capsule, and then we can go for the dissolution apparatus USP2, and with the all specification we can conduct in vitro drug release studies of the SMEDDS. Finally, we need to analyze the sample that shows that how much amount of drug is getting released in a particular time. Next evaluation test is droplet size analysis and zeta potential measurement, which are very important tests for SMEDDS. So that is determined by photon correlation spectroscopy using Malvern zeta sizer at 25 degrees Celsius. So this is one single instrument which gives us both the readings for droplet size as well as for zeta potential. So here we need to disperse the formulation into 100 milliliter of distilled water, and then 1 ml of this particular dispersion we can use in the sample cell. We need to fill the sample cell with this aliquot, 1 ml of aliquot, and then we just monitor light scattering at 90 degree to incident beam on sample. So this instrument directly gives us readings for droplet size and zeta potential. Zeta potential is actually very important parameter which is directly related to the stability of the resultant emulsion. If the zeta potential value is at higher side, that indicate more stable resultant emulsion. Why? Because zeta potential is nothing but the net charge onto the droplets. So if the net charge value is high, its magnitude is high, that indicates that all the droplets in a way they'll repel each other. So this will ultimately inhibit any type of coalescence or phase separation of the resultant emulsion. So zeta potential measurement is very important, and preferably the value for zeta potential should be near to 30 millivolt. The charges can be plus or minus based on which type of oil we are using or which type of substance they are present on the droplets, but the magnitude should be near to 30 millivolt. Another test which are there for self-emulsifying drug delivery system, their viscosity, so that we can measure by viscometer. We can go for Brookfield viscometer. Next is refractive index, so that we can measure with the help of refractometer. And finally, we can compare the refractive index of the formulation with the refractive index of water. The other test is percentage transmittance, which is a special test for SMEDDS. So here we measure the transmittance at a particular wavelength using UV spectrophotometer. And one more test, it is a turbidimetric evaluation that we do with the help of nephelometer, and it is being performed to monitor the growth of emulsification. So as the emulsification process will grow, that will be indicated by nephelometer. So this was all about the evaluation of self microemulsifying system. Thank you.